Hi class, this is Sir Alex Basco and welcome to our lesson in General Chemistry 1. We are going to move on to lesson 4, beginning with lesson 4.1. And lesson 4.1 will revolve around stoichiometry, basic one. And in order for you to understand stoichiometry, we have to first understand what moles and molar mass is. So today the whole bulk of our discussion is using moles and molar mass to understand the relationship between the two and how we use them when we're measuring mass of very small particles such as the atoms and the elements that we use in chemistry. So at the end of today's lesson, what I want everyone be able to do first is I want you guys to be able to calculate the empirical formula. I hope you remember what empirical formula is. They're the most basic formula of any compound from the percent composition of a compound. So if you know the percent composition of a compound, how can you identify the empirical formula? And also be able to calculate the molecular formula. Okay, so I hope you remember what molecular formula is. It's basically a formula that shows all the elemental makeup that makes a compound. So if you have a molar mass of a compound, how can you identify its molecular formula? But before you can all do this, you have to understand molar mass and moles. So we're not going to do a lot of calculation of empirical and molecular formula yet. What we're going to do is calculate molar masses, moles, and what we call Avogadro's number. So let's go ahead and understand what those means. So let's begin by understanding what is stoichiometry. Stoichiometry is basically a type of quantitative relationship between the reactants and a products in a chemical reaction. Just to make sure, I'm not sure if you guys know what reactants and products are. So in chemistry, you usually see something like this. So if you have oxygen plus hydrogen, and then you ended up having um, H2O. Okay, so this is a type of relationship between what we call a reactants and a products. Your reactants are the elements you're trying to react together, the ones that you're trying to combine. So in this situation, these are my reactants. And if these two elements reacted together, I'm creating a product. So in stoichiometry, you want to know the relationship, more specifically the quantitative relationship, the number relationship between these reactants and products. But before you can do that, you have to understand what we call the moles, molar mass, and Avogadro's number. So we're not gonna go delve into stoichiometry yet. That's actually something that you would learn in general chemistry too. Today, what we're going to do is understand what moles, molar mass, and Avogadro's is by first talking about mole. Mole is an SI unit of measurement. Just remember that international standard unit of measurement, meaning it is used everywhere. Yes, even in the US, who uses a different set of standard of measurements. But in chemistry, we use mole as a type of measurement when we want to measure large number or large quantities of very small particles. So meaning the small particles are the atoms or like the molecules. We know that oxygen and hydrogen, even water molecules, are very small because we cannot see them with our own very eyes. So we need a way in order for us to be able to measure them. What we do is we take a lot of number of oxygen and then we can actually weigh it, or take a lot of number of hydrogen or any of elements basically, and then if we know the mass of our various number of atoms, so because we because we want to measure them, what we do is we take a very large quantity and we create an SI unit of measurement called moles. You can think of moles as like a dozen. You know, dozen means 12 pieces. So if you have like a dozen eggs means 12 pieces. One mole is basically a very large quantity of oxygen. And there's actually a very specific number of a large quantity of oxygen later that we call the Avogadro's number. Next, let's talk about molar mass. Molar mass is the atomic mass of an atom expressed in grams per mole. So what is atomic mass? Let's say if you look at the periodic table, you would always see two numbers on each element. Here's a carbon. You would see a number on top of a carbon, and then you would see a number at the bottom. The top here, this atomic number is basically the number of protons. Atomic number is actually the number of protons that the element has. In lesson 3.2, if you remember, when we're talking about valence shell, the example that we have on the video lesson is an example of a carbon, and the carbon has 6 protons. So if you count the protons inside the picture there, you would see 6 protons, and that tells you that this is a carbon. So we're not dealing with that. What we are interested in is the atomic mass. Atomic mass is basically the weight um, in amounts AMU, we call it atomic mass unit. So this is 12 AMU per carbon. In order for you to get the molar mass, what you just want to do is take this molar mass and express it instead of AMU to grams per mole. So the molar mass of carbon is basically equal to 12.01 grams per mole. So what you want to do is multiply it to a molar mass constant of 1 gram per mole. Easy enough. So that's the molar mass of every element. So I hope you guys remember that, what molar mass is. Next, let's talk about Avogadro's number. Avogadro's number is equals to 6.022. Mostly we just stop here, 0.022, but if you want to include this, that's on you, but 0.06.022 is enough, times 10 raised to 23 particles. What do we mean by that is this is the number of atoms in a single mass. So in a single mole. So what do we mean by that? Okay, so 1 mole, like I mentioned, in order to write mole, you can just write MOL. So that's how we write mole in SI unit, MOL. 1 mole is actually equal to 1 molar mass of an element. And that 1 molar mass is equals to 1 Avogadro's number. So meaning you have 6.22 times 10 raised to 23 atoms or particles. In this case, they're all atoms. So what do we mean by that? If I have 1 mole of carbon, that 1 mole of carbon is equals to 12.01 grams. Its atomic mass. And that is actually equal to 6.022 times 10 6.022 times 10 raised to 23 atoms. What does this mean is if I have a 12 grams of carbon, that 12 grams of carbon has an approximate number of 6.22 times 10 raised to 23 atoms of carbon. So that's a lot of carbon, right? So if I bunch up enough carbons, so single atom, and then if I have about this much atoms of carbon, it will actually weight about 12.01 grams. And this is equal to 1 mole. So 1 mole of carbon is equals to its molar mass, which is 12.01 grams and per mole, and then is equals to its atomic mass basically, and then that is equals to 6.022 times 10 raised to 23 atoms. Interesting enough. So if we look at 1 mole of oxygen, interestingly, 1 mole of oxygen, so if you look at the table, oxygen has 16 here, and oxygen is actually 16, no, sorry, this is supposed to be 8, has 8 protons. And this is actually about 16.00, I believe, 1. So that's 16 there. So the atomic mass of oxygen is equals to 16.00. So 1 mole of oxygen is about equal to its atomic mass. So if I have 16.0 grams of oxygen, I basically have about 1 mole. Okay, so in 1 mole of oxygen, that is actually equal to 16 grams. And the 16 grams of oxygen is actually about equal to 6.022 times 10 raised to 23 atoms of oxygen. So this is the relationship between mole, molar mass, and Avogadro's number. Avogadro's number is basically how many particles of element do I have? So if I have 12 grams of carbon, it means that 12.01 grams of carbon has an approximately 0.022 times 10 raised to 23 atoms of carbon. If I have 16 grams of carbon, I have about 6.022 times 10 raised to 23 atoms of oxygen. And all of these is equal to their 1 mole. So 1 mole of carbon is equals to that, is equals to that. So that is the relationship that I want you guys to remember. Now let's go ahead and try to apply this knowledge to some sample problems. Let's look at sample problem number 1, 4.1.1. So if I have a mass, if I have a 5 moles of carbon, what would be its mass? So let's write our given. Our given had in our given they gave us the mole of carbon, which is equals to 5 mole. What do we know about carbon is that its molar mass. The molar masses are easy to identify, especially in single element or in a single monoatoms in a single atom. This is because you can just look at the periodic table. We know that the molar mass. So just take the atomic mass and then divide it by mole. So the molar mass of carbon is about equal to 12.01 grams per mole. Again, so where did I get this? It's just on the periodic table of elements. Just look at the atomic number, the number at the bottom, and then take that and make it grams per mole. So that is its molar mass. And then what is asking us? What is being asked? It's asking me the mass. So if I have 5 moles of carbon, and I know that the molar mass of carbon is 12.01 grams per mole, then how much weight of carbon do I have? So in order for us to solve this, it's quite very easy. So you can see this is small, and I'm looking for grams. I'm looking for a certain amount of grams. And what I want to do is basically multiply the two. In order for me to find the mass of carbon, what I need to do is basically multiply the moles of carbon to the molar mass of carbon. So that is equal to 5 moles multiplied by 12.01 grams per mole. So the mole get cancelled. What I have left is grams. So 12.01 times 5 is equal to 60.05. Yes, take 60 times 60.05 grams. So in 5 mole of carbon is equals to about 60.05 grams of carbon. Clear enough? So that's how you find mass. How did I know this is what I need to do? This is because look at units. The units of molar mass is grams per mole. And I'm looking for grams. That's what is being asked of me. So what do I need to remove this? Basically, I need to multiply this into a mole unit. And the mole get cancelled. I'm left with grams. And I know that the mole unit is basically moles. And that's what's given to me. So multiplying these two will give me the grams of carbon. Let's continue on and look at the next sample problem. Let's look at this. How many moles are present in 65.60 grams of carbon? So earlier, what we were looking is the weight of carbon after they gave us the moles. This time, we're gonna invert it a little bit. So what we're looking for now is how many moles of carbon do I have if I have 25 grams of carbon? Earlier, we know that in 60 grams of carbon, about 60.05 grams of carbon, there's 5 moles. That was the sample problem 4.1.1. But this one, we're looking for the moles. So what they gave us is we have the grams, basically the mass of our carbon is equal to 25.60 grams. Again, we know that the molecular mass of my carbon is equals to 12.01 grams per mole. And what they are asking me is how many moles of carbon is 25.60 grams of carbon. So they're asking me for moles. So how am I going to solve for this? Still quite easy, so let's have our solution right here. In order for me to find the moles of carbon, what I need to do here is actually basically um, sorry, you have to invert your molar mass. Your molar mass is equals to 12.01 grams per mole, correct? That is equal to this one. That's basically grams per mole. So what this means is I have in every 1 mole of carbon, I have 12.01 grams of carbon. Since I'm looking for mole, what I need to do is basically I can invert this. That would give me 1 mole is equals to 12.01 grams of carbon. And then if I multiply that to the given grams of carbon, 25.60 grams, then I can cancel the grams and I'm left with moles. So basically what I would have is 25.60 divided by 12.01. And that is actually equal to about 2.13 mole of carbon. Okay, so I hope it's clear how are this relationship happening. And this makes sense because I know that 1 mole is equals to 12.01. And 25 is about twice the amount of 12.01. So meaning the mole of carbon I have is about 2. So to know specifically how much carbon do I have, I just need to divide this to the number of grams. So that's 25.60 divided by 12.01. That's 2.13 moles of carbon. I hope that is clear. Let's go on and continue on with our problem. So what is the mass of 1.086 times 10 raised to 24 atoms of carbon? So this time now I'm looking for the mass of the carbon and they gave me the number of particles of atoms I have. This is now where I need to use the Avogadro's numbers. Let's write our given. I am given that the number of atoms I have, let's number of carbon atoms that they gave me is equals to 1.086 times 10 raised to 24 atoms. And I know that the molar mass of carbon is about equal to 12.01 grams. Correct? That's a given. And I know Avogadro's number. Avogadro's number. And that's actually equal to 6.022 times 10 raised to 23 atoms. And based on our discussion earlier, this Avogadro's number is actually equal to 1. mole. So it should be grams per mole. This is, we know that this is equal to mole. So how are we going to find what they're asking us? Is the mass of carbon. So how are we going to solve this? Well, we're looking for the mass. So the end goal is in grams. So in order for us to find that, we have to understand that in each 12.0 grams of carbon, there is 1 mole. So meaning in 1 mole of carbon, that is equals to 12.01 grams. And we know that 1 mole of any element is equals to 6.022 times 10 raised to 23 atoms of that element. So what I'm gonna do is I'm gonna take my Avogadro's number, mass of carbon is equals to, I'm gonna take the Avogadro's number 6.022 times 10 raised to 23 atoms. And I know that this is actually equal to 1 mole. So 1 mole, 1 mole of any element, so in this case 1 mole of carbon is equal to, oh sorry, my mistake, I'm gonna take the number of particles here, so 1.086 times 10 raised to 24 atoms. So I have this much particles, and I know that in every mole of any element, that is actually equals to 6.022 times 10 raised to 23 atoms. This is true for any element. Okay, so 1 mole of any element is equals to this number of particles. So the atoms get cancelled. But I'm looking for mass, I'm not looking for moles. Still I'm in mole. So what I'm gonna do is I have to cancel the mole. And I know that in every 12 grams of my carbon, 12.01 grams of carbon is equal to 1 mole of carbon. The mole gets cancelled. Now I am left with this equation. So what I'm going to do is basically take the number of atoms right here multiplied by 12.01 divided by the number of particles, and that will give me the mass, and this is actually equal to 36.02 grams of carbon. So 36.02 grams of carbon has about 1.086 times 10 raised to the 24 atoms. So that's the number of particles of atoms I have. Let's continue on with our last sample problem. How many individual atoms? This time I'm looking for how many atoms I have. Our third problem, 4.1.3, they gave us, let's go back, they gave us the number of atoms. I'm looking for mass, but this time they gave me the mass of my carbon, and I'm looking for the number of particles I have. So what is given to me is the mass of carbon, and that is actually equals to 24.80 grams. I know that the molar mass of my carbon is equal to 12.01 grams per mole. I know that any 1 mole of any element, in this case element, is equals to Avogadro's number, which is 0.06.022 times 10 raised to 23 atoms. This is my Avogadro's number. And what I'm being asked is how many is the number of carbon atoms. So my end goal is to identify how many how many carbon particles I have. So let's write our solution. In order for me to do this, what I'm going to do is I'm going to take my grams. So the number of carbon atoms is equals to my grams, which is 24.80 grams. What I'm gonna do is have to remove grams, and I can do that by having a relationship with my molecular mass. So I'm going to put my grams underneath, and that would leave me 1 mole per 12.01 grams. So the grams gets cancelled. I am left with 1 mole. And since I'm looking for atoms, I need to have my atoms basically at my numerator, so I have to remove moles. And here I know that any 1 mole of any element, so the mole gets cancelled, any 1 mole of any element, in this case carbon, is equals to 6.022 times 10 raised to 23 atoms. So the moles get cancelled, the grams get cancelled, I'm left with atoms. So now what I have, I can now measure how many atoms I have. So we have 24.80 times 6.022 times 10 raised to 23, everything divided by 12.01. So just use the calculator and you would find that in 24.80 grams of carbon, there are about 1.24 times 10 raised to 24 carbon atoms. So that's how you use the relationship between each of the particles that we're talking about, the moles, the molar mass, and how to use the Avogadro's number when you want to identify how many individual atoms a particular weight of element has, or a particular molecular weight of an element has. I hope it's clear. I hope you guys didn't get confused. If you guys have ever got confused, do not hesitate again to message me, and may you guys have a great